Megger test is used to evaluate the insulation resistance of a motor. The Megger value is measured in megohms. The higher the Megger value, the better the insulation resistance. Acceptable Megger values for motors vary depending on the voltage rating of the motor. For low voltage motors, which are those less than 1 kV, the acceptable Megger value is typically 1 megohm or higher. For medium voltage motors, ranging from 1 kV to 5 kV, the acceptable Megger value is generally 2 megohms or higher. For high voltage motors, those exceeding 5 kV, a Megger value of 5 megohms or higher is usually considered acceptable. While there are no industry-wide standards specifically for Megger testing of motors, organizations like the Institute of Electrical and Electronics Engineers, or IEEE, and the National Fire Protection Association, or NFPA, provide guidelines for assessing insulation resistance. IEEE 43, titled Recommended Practice for Testing Insulation Resistance of Rotating Machines, offers guidance on this topic. NFPA 70E, the standard for electrical safety in a workplace, also includes relevant information. These guidelines often recommend using a Megger test voltage of twice the motor's rated voltage, or 500 volts, whichever is higher. When interpreting Megger test results, a value significantly below the recommended threshold suggests a potential problem with the insulation. This could be due to moisture or contamination buildup, damage to the winding insulation, or even ground faults. In such cases, further investigation is necessary to pinpoint and resolve the underlying issue. It's important to remember that the Megger test is just one part of a complete motor inspection. Other factors, such as the motor's temperature, vibration levels, and operating history, should also be considered when evaluating the motor's overall condition. When performing a Megger test, safety is paramount. Always de-energize and lock out the motor before connecting the Megger. Ensure that all personnel are clear of the equipment during the test. Use properly insulated test leads and wear appropriate personal protective equipment, or PPE, including gloves and safety glasses. Never perform a Megger test on a motor that is wet or located in a damp environment. This can lead to inaccurate readings and potential electrical hazards. Before connecting the Megger, clean the motor windings and terminals to remove any dirt, grease, or other contaminants. This will help to ensure accurate readings. Select the appropriate test voltage in the Megger, typically twice the motor's rated voltage or 500 volts, whichever is higher. Connect the Megger test leads to the motor windings and ground. Apply the test voltage for a specified period, typically 1 minute. Record the Megger reading at the end of the test period. Compare the Megger reading to the recommended threshold for the motor's voltage rating. If the Megger reading is below the threshold, investigate the cause of the low insulation resistance. This may involve inspecting the motor windings for damage, checking for moisture or contamination, and performing other tests. If the Megger reading is above the threshold, the motor insulation is likely in good condition. However, it is still important to monitor the motor's insulation resistance over time to detect any potential problems early. Remember, Megger testing is a valuable tool for assessing the condition of motor insulation. By following proper procedures and interpreting the results correctly, you can help to ensure the reliable operation of your motors. The interpretation of Megger test results requires careful consideration of several factors. Firstly, the temperature of the motor windings can significantly affect the insulation resistance. Higher temperatures generally lead to lower resistance readings. Therefore, it's essential to correct the Megger reading for temperature variations, especially when comparing readings taken at different times or under different operating conditions. Correction factors can be found in IEEE 43 and other relevant standards. Secondly, the presence of moisture or contamination can also lower the insulation resistance. If the motor has been exposed to moisture, such as from condensation or leaks, it should be thoroughly dried before performing a Megger test. Similarly, if the windings are coated with dirt, grease, or other contaminants, they should be cleaned prior to testing. Thirdly, the age of the motor can influence the insulation resistance. As motors age, the insulation material can degrade over time due to thermal stress, vibration, and other factors. This degradation can lead to a gradual decrease in insulation resistance. Therefore, it's important to establish a baseline Megger reading for each motor when it is new or in good condition. This baseline reading can then be used to track changes in insulation resistance over time. Fourthly, the type of insulation material used in the motor windings can affect the Megger reading. Different insulation materials have different dielectric properties which can influence the amount of current that flows through the insulation under test voltage. Therefore, it's important to be aware of the type of insulation material used in the motor when interpreting Megger test results. Fifthly, the test voltage used during the Megger test can affect the reading. Applying a higher test voltage can stress the insulation more, potentially revealing weaknesses or faults that might not be detected at a lower voltage. However, it's important to use the correct test voltage for the motor's voltage rating to avoid damaging the insulation. Sixthly, the duration of the Megger test can influence the reading. Insulation resistance typically increases over time as the insulation material becomes more polarized under the influence of the test voltage. Therefore, it's important to apply the test voltage for a sufficient period, typically 1 minute, to allow the insulation resistance to stabilize. Seventhly, the condition of the Megger instrument itself can affect the accuracy of the readings. It's important to ensure that the Megger is properly calibrated and in good working condition before performing any tests. Regular calibration and maintenance can help to ensure accurate and reliable results. Eighthly, the presence of any external electrical fields can influence the Megger reading. Therefore, it's important to perform the Megger test in a location that is free from strong electrical fields, such as those generated by nearby power lines or electrical equipment. Ninthly, the grounding of the motor frame can affect the Megger reading. It's important to ensure that the motor frame is properly grounded during the test to provide a return path for any leakage current. Tenthly, the temperature of the surrounding environment can influence the Megger reading. Extreme temperatures can affect the dielectric properties of the insulation material, potentially leading to inaccurate readings. Therefore, it's important to perform the Megger test in a stable temperature environment. In addition to these factors, it's also important to consider the motor's operating history when interpreting Megger test results. Motors that have been subjected to frequent starts and stops, heavy loads, or harsh environmental conditions may experience accelerated insulation degradation. Therefore, it's important to monitor the insulation resistance of these motors more closely. Furthermore, it's important to keep accurate records of all Megger test results. These records can be used to track changes in insulation resistance over time and to identify potential problems early. By carefully considering all of these factors, you can improve the accuracy and reliability of your Megger test results and make more informed decisions about motor maintenance and repair. Remember, Megger testing is a valuable tool for assessing the condition of motor insulation, but it's only one piece of the puzzle. A comprehensive motor inspection should also include visual inspections, vibration analysis, and other tests to provide a complete picture of the motor's health. Now let's delve deeper into the practical aspects of conducting a Megger test. Before starting, gather the necessary equipment. This includes the Meggometer itself, also known as a Megger, appropriately rated test leads, personal protective equipment such as safety glasses and insulated gloves, and a lockout-tagout device for ensuring the motor is de-energized during the test. Firstly, ensure the motor is completely de-energized and locked out. This is a critical safety step to prevent accidental energization during the test. Verify that the motor cannot be started remotely. Secondly, visually inspect the motor for any signs of physical damage, such as cracked insulation, loose connections, or evidence of overheating. Document any findings. Thirdly, clean the motor windings and terminals. Use a clean, dry cloth to remove any dirt, dust, or debris that could affect the accuracy of the test. Fourthly, disconnect the motor leads from the power source. This isolates the motor windings for testing. Fifthly, connect the Megger test leads. Connect one lead to a motor winding and the other lead to the motor frame or ground. Sixthly, select the appropriate test voltage. As mentioned earlier, this is typically twice the motor's rated voltage or 500 volts, whichever is higher. Consult the motor's nameplate for the rated voltage. Seventhly, apply the test voltage and observe the Megger reading. Start the Megger and apply the test voltage for a predetermined time, usually 1 minute. Note the resistance reading in megohms. Eighthly, record the Megger reading and relevant information. Document the date, time, motor identification, test voltage, and Megger reading. This information is essential for tracking trends over time. Ninthly, discharge the motor windings after the test. Some Meggers have an automatic discharge function. If not, use a grounding stick to safely discharge any residual voltage in the windings. Tenthly, reconnect the motor lead and remove the lockout/tagout device. Only do this after confirming the motor is safe to re-energize. Following these steps carefully will help ensure a safe and accurate Megger test. Remember to always prioritize safety and consult the manufacturer's instructions for your specific Megger model. Additionally, it's worthwhile to discuss some common pitfalls to avoid when performing Megger tests. One common mistake is using an incorrect test voltage. Using too low of a voltage may not reveal insulation weaknesses, while using too high of a voltage can damage the insulation. Another pitfall is failing to properly clean the motor windings. Dirt and debris can create a false reading and mask underlying insulation problems. Ignoring temperature and humidity is also a common error. These environmental factors can significantly affect insulation resistance, so it's crucial to account for them when interpreting results. Another mistake is not allowing enough time for the reading to stabilize. Insulation resistance typically increases over time as the insulation polarizes, so a 1-minute test duration is generally recommended. Lastly, neglecting to document the test results properly can hinder future analysis and trend tracking. Now, let's consider the importance of trending Megger test data over time. A single Megger reading provides a snapshot of the insulation condition at a specific point in time. However, tracking these readings over time can reveal valuable insights into the rate of insulation degradation. A sudden drop in insulation resistance may indicate a developing problem, such as moisture ingress or insulation breakdown. By regularly performing Megger tests and analyzing the trends, you can proactively identify and address potential issues before they lead to motor failure. This predictive maintenance approach can save time, money, and prevent unexpected downtime. Furthermore, consider the role of Megger testing in a comprehensive motor maintenance program. While Megger testing is a valuable tool, it's just one component of a holistic approach to motor maintenance. A comprehensive program should also include visual inspections, vibration analysis, oil analysis, and thermography. Combining these techniques provides a more complete picture of the motor's overall health and allows for more informed maintenance decisions. Regular visual inspections can reveal signs of physical damage, such as cracked insulation, loose connections, or oil leaks. Vibration analysis can detect imbalances, misalignments, and bearing problems. Oil analysis can assess the condition of the lubricant and identify contaminants. Thermography can detect hotspots caused by overheating or electrical faults. By integrating Megger testing with these other techniques, you can create a robust motor maintenance program that maximizes reliability and minimizes downtime. In conclusion, the Megger test is a powerful tool for evaluating the insulation resistance of electric motors. By understanding the principles behind the test, following proper procedures, and carefully interpreting the results, you can help to ensure the reliable operation of your motors and prevent costly failures. Remember to prioritize safety, account for environmental factors, and trend the data over time to gain valuable insights into the condition of your motor insulation. Incorporate Megger testing into a comprehensive motor maintenance program to achieve optimal performance and longevity.